Now we have some problems that require us to perform operations with radicals. Specifically, we want to add or subtract radicals. Number 13 is 4 on the square root of 3 minus the square root of 3. Recall these are like radicals because they have the same index and the same radicand. We then combine their coefficients, and that would be 4 minus 1, which is 3, and the radical factor stays the same, so 3 radical 3. 5 on the square root of 2 plus 4 on the square root of 2. We just add the coefficients to get 9 on the square root of 2. 3 on the square root of 7 minus 2 on the square root of 28. Before we can combine them, we need to simplify any radicals. So we first recognize that 28 can be written as 4 times 7, right? We're looking for a perfect square factor. We simplify this to be 3 on the square root of 7 minus 2 times 2 on the square root of 7. So this is 3 on the square root of 7 minus 4 on the square root of 7. And that is negative 1, or just simply negative square root of 7. 4 on the square root of 20 plus 9 on the square root of 45. We can write 20 as 4 times 5. 45 can be written as 9 times 5. This simplifies to be 4 times 2 on the square root of 5 plus 9 times 3 on the square root of 5. Now we have 8 on the square root of 5 plus 27 on the square root of 5, and that simplifies to be 35 on the square root of 5. The next skill continues with radical expressions, but now it looks at simplifying the square of an expression. Number 17 is to square the square root of 3, and that is simply 3. So here we're applying the fact that the square root of x squared is just simply x. The square root of x plus 3 all squared is just x plus 3. X plus 3 squared, remember that is squaring a binomial, so we would have either x plus 3 times x plus 3, or you can apply a squaring pattern, but the idea is that we distribute to get x squared plus 3x plus 3x plus 9. So this is x squared plus 6x plus 9. And number 20 is very similar, except that it has a square root of x plus 3 squared. So this would be the square root of x plus 3 times the square root of x plus 3. So here, square root of x times the square root of x is really the square root of x squared, which is just x. Square root of x times 3 is plus 3 on the square root of x, plus 3 on the square root of x, plus 3 times 3, or 9. This simplifies then to be x plus 6 on the square root of x plus 9. The square root of x plus the square root of 3 squared, very similarly, we repeat that base square root of x plus 3 and multiply it by itself. So square root of x times square root of x is just x. Square root of x times the square root of 3 is the square root of 3x plus square root of 3 times the square root of x is the square root of 3x plus square root of 3 times the square root of 3 is just 3. So we have x plus 2 times the square root of 3x plus 3. Right, keep in mind that the square root of 3x plus the square root of 3x are like radicals, so we just add their coefficients. Square root of 3 plus 7 squared, is square root of 3 plus 7 times square root of 3 plus 7. Square root of 3 times the square root of 3 is just 3. Square root of 3 times 7 is plus 7 on the square root of 3. Plus 7 times the square root of 3 is plus 7 on the square root of 3. Plus 7 times 7 is plus 49. Combining like terms gives us 52 plus 14 radical 3. Now to simplify an expression with a rational exponent, so recall that x to the 1 over n is the nth root of x. X to the m divided by n is the nth root of x to the m. 144 to the 1/2 is the square root of 144, or 12. 32 to the 4/5 is the 5th root of 32 raised to the 4th. And so the 5th root of 32 is 2, and 2 to the 4th is 16. X to the 1/4 to the 4th, when we raise an exponential expression to another exponent, we multiply exponents. So we would say x to the 1/4 times 4, which is just 4/4 or 1. So it's simply x to the 1st, or x. A to the 3/2 squared would be a to the 3/2 times 2. But the 2 is really 2 over 1, so those 2's divide out to left with a to the 3. And the last skill in this section was to be able to use substitution to rewrite an expression. So here you want to complete the chart by writing the equation that results from making the u substitution. Number 27 was the equation x squared plus 2 squared plus x squared plus 2 minus 42 equals 0. And we want to let u equal x squared plus 2. So if u is x squared plus 2, our equation then becomes u squared plus u minus 42 equals 0. Number 28 is 5c to the 2/5 minus 11c to the 1/5 plus 2 equals 0. And we want to make this substitution that u equals c to the 1/5. So recall that if u is equal to c to the 1/5, then u squared is c to the 1/5 squared. And that would mean for us to multiply those exponents. 1/5 times 2 is 2/5. So in place of c to the 2/5, we're going to put in u squared. So this equation really becomes 5u squared minus 11u plus 2 equals 0. And keep in mind, you're trying to get a quadratic equation, so you need a u squared and a u in the resulting equation. 29 is 1 divided by a minus 2 squared plus 3 divided by a minus 2 equals 4. And our substitution expression is that u is a minus 2 to the negative 1. Well, recall that a minus 2 to the negative 1 is really 1 divided by a minus 2 to the first, or just 1 divided by a minus 2. So we see here that we have 1 divided by a minus 2 squared. And if we square the 1 divided by a minus 2, we will actually get (1 divided by a minus 2 squared). And if you don't like it like that, we can actually rewrite this equation to be a minus 2 to the negative 2 plus 3 times a minus 2 to the negative 1. equals 4. And so when we make this substitution of a minus 2 to the negative 1, we would really get u squared plus 3u equals 4.